Hey there, and welcome back to the channel. I'm really glad you're here, because today we're going to demystify one of those AWS pieces that quietly powers almost every serious cloud setup, but rarely gets explained well: the NAT Gateway. By the end of this video, you'll understand exactly how a private server, one with no public address at all, can still safely reach out to the internet to grab updates or call an API, all while staying completely hidden from the outside world. We'll go step by step: what a NAT gateway actually is, why you need one, how the traffic physically flows, and when you should and shouldn't use it. No hand-waving, we'll really get under the hood. So let's ease in. Let's start with the simple definition. A NAT gateway is a managed service from AWS, and that word managed matters because it means AWS runs it, scales it, and keeps it highly available for you. You don't patch it or babysit it. Its one job is to let your private instances reach the internet in the outbound direction without those instances ever having a public IP address of their own. Think about that for a second, because it's the whole magic trick. Normally, to talk to the internet, a server needs a public address so replies know where to come back. NAT lets a server skip that entirely. The instance keeps only its private internal address, and the NAT gateway acts as a middleman that goes out to the internet on its behalf. That separation is the heart of everything we'll cover today. Here's the mental picture I want you to lock in. A NAT gateway is a one-way exit door. Picture your private EC2 instance sitting inside a locked building with no street-facing entrance. It can walk out through this exit door, do its errand on the internet, and come back in, but nobody on the street can use that door to walk into the building. Traffic flows out, and the responses to that traffic flow back in, but a stranger on the internet can never start a conversation with your private server. They can't even see it because it has no public IP. That's why we call it a one-way exit. Private subnets reach out, the internet cannot reach in. Hold on to that image, because every detail that follows is really just an explanation of how AWS makes that one-way door work. Now you might be wondering, if these servers are supposed to be private and hidden, why do they need the internet at all? And this is a really common point of confusion. People assume private means cut off from everything. But in the real world, even a server you never want the public to touch still has errands to run. Look at the screen. A private instance at address 10.0.2.10 wants to run something like sudo apt update to refresh its software list, or Docker pull to download the latest version of an application image. Both of those reach out to servers on the internet. The server needs to initiate those connections, but it absolutely should not be exposed publicly while doing so. That tension, needing outbound access without inbound exposure, is the exact problem NAT was invented to solve. Let's make those needs concrete, because they come up constantly. First, operating system updates and security patches. Your servers have to download fixes for newly discovered vulnerabilities, and if they can't, they slowly rot into a security risk. Second, installing software packages. When you spin up a new app server, it pulls libraries and dependencies from package repositories out on the internet. Third, calling external APIs. Maybe your app sends a text message through a service like Twilio or charges a card through Stripe. Those calls go outbound to a third party. Fourth, pulling Docker images from registries like Docker Hub or Amazon's own. And fifth, talking to all sorts of third-party services your application depends on. Every one of these is outbound, initiated by your server, and none of them requires the outside world to be able to reach in. That's the perfect job for a NAT gateway. Okay, so how does the traffic actually travel? Let's trace the path shown here from left to right. Your private EC2 instance sends a request. That request doesn't go straight to the internet. It gets routed to the NAT gateway. Now here's a key detail. The NAT gateway itself does not live in the private subnet with your server. It lives in a public subnet, and it has an elastic IP. That's a fixed, static public address that belongs to it. From the NAT gateway, the traffic then passes through the internet gateway, which is the VPC's actual door to the public internet, and finally out to the destination. So the chain is private EC2, then NAT with its elastic IP, then internet gateway, then the internet. And notice the label, outbound traffic only. The whole arrangement is built so requests can flow out and answers can flow back, but nothing new can push in. Let me really hammer on this direction point, because it's where the safety comes from. Outbound is allowed. Your private servers reach out, and the responses to their requests are allowed to return, because the NAT gateway remembers that your server started that conversation, so it knows where to send the reply. But inbound is blocked. The internet cannot start a brand new connection into your private servers. Think of a phone call. You can call out and the person you called can talk back to you on that same call, but a random stranger can't dial in and reach you because they have no number to call. There's no public IP, no open door, nothing for an attacker to knock on. This asymmetry, replies welcome, cold calls rejected, is exactly what makes a private subnet behind NAT both useful and secure. Now, how does AWS actually steer the traffic to the NAT gateway? Through something called a route table, essentially a set of signposts that tell network traffic where to go next based on its destination. This is the route table attached to your private subnet, and it has two rules. The first says, any traffic headed for 10.out/16, that's your own VPC's internal address range, stays local, meaning it just routes inside your network. The second rule is the important one, 0.0.0.0/0, which is shorthand for everywhere else the entire internet gets sent to the NAT gateway. So when your private server tries to reach some address out on the public internet, the route table catches it under that catch-all rule and forwards it to NAT. That single line, 00.0.0/0 pointing to the NAT gateway, is what wires your private subnet to its one-way exit. Here's the companion piece, the route table for the public subnet, the one where the NAT gateway actually lives. It also has the local rule for internal VPC traffic, 10.0.0/16 staying local. But its catch-all rule, 0.0.0/0, points not to a NAT gateway, but to the internet gateway directly. And this is why the NAT has to sit in the public subnet in the first place. The NAT gateway itself needs a clear path to the internet to do its job, and that path comes from the internet gateway. So picture the relay. Your private subnet's route table sends internet-bound traffic to NAT. NAT sits in the public subnet, whose route table sends that traffic onward to the internet gateway and out. Two route tables working together, each pointing one hop further toward the open internet. Now let's look at the clever bit that makes all of this actually work. Network address translation, which is literally what the letters NAT stand for. Watch what happens to the address. Before NAT, the request leaves your private EC2 instance carrying its source address of 10.0.2.10, a private address that means nothing on the public internet and could never receive a reply. So the NAT gateway rewrites it. After NAT, the request goes out carrying the NAT gateway's elastic IP instead, here, 13.4.5.6.7.89. The destination server on the internet sees only that public address and sends its reply back to it. The NAT gateway, remembering which internal server made the request, then forwards the reply back to 10.2.10. So your private IP is never exposed to the outside. The internet only ever sees the NAT's elastic IP. That swap is the literal mechanism behind the whole one-way door. At this point, a really natural question comes up. How is this different from an internet gateway? People mix these two up all the time, so let's lay them side by side, starting with the NAT gateway. Where is it used? In private subnets. What direction does it allow? Outbound only, out and back, never in. Does the private EC2 behind it need a public IP? No, and that's the entire point. The instances stay addressless to the public world. And what's it best for? Letting private application servers do things like fetch updates and call APIs while staying hidden. Keep this card in mind because the next slide is its mirror image. And here's the contrast, the internet gateway. Where is it used? At the public subnet level. Really, it's attached to the whole VPC as its front door. What direction does it allow? Two-way, both inbound and outbound. A resource using it can be reached from the internet and reach out to it. Does the resource need a public IP? Yes, anything using the internet gateway to talk to the world needs its own public address. And what's it best for? Things meant to be reachable from the internet, like a public web server or a load balancer that users connect to directly. So the simple way to remember it, Internet Gateway is the two-way public door for things that should be reachable. NAT Gateway is the one-way private exit for things that should stay hidden but still need to step out. So how do you decide when you actually need a NAT gateway? There's one simple question that cuts right to it, and it's the one on screen. Does this server need the internet, but also need to stay private? Whenever you find yourself wanting both of those things at once, outbound access and no public exposure, that's the signal that NAT is the right tool. Let's walk through the cases where the answer is clearly yes, and then the cases where you can happily skip it. Here's when NAT Gateway genuinely fits. First, your EC2 instance lives in a private subnet. It's deliberately tucked away from the public internet. Second, it should not have a public IP. You've decided for security that it stays unreachable from outside. Third, despite that, it needs outbound internet access to function. And fourth, the classic case, application servers that need to pull down updates or reach out to external APIs to do their work. When all of these line up, private placement, no public address, but a real need to reach out, the NAT Gateway is exactly what you deploy. This is the everyday situation for the back-end tier of most production applications. But it's just as important to know when you don't need one, because a NAT gateway costs money and adding it blindly is wasteful. Skip it in these cases. First, if your EC2 is in a public subnet and already uses the Internet Gateway directly, it doesn't need NAT on top of that. Second, if the server genuinely needs no internet access at all, a database that only talks to your app servers, for instance, has no reason to reach out. Third, and this one's a money saver worth knowing, if you only need to reach AWS's own services like S3 or DynamoDB, you can use VPC endpoints, which give private servers a direct private path to those services without routing through NAT and paying for the traffic. And fourth, if the server is meant to be fully isolated by design, leave it that way. Matching the tool to the actual need keeps your setup both cheaper and safer. Let's tie all of this together with a real-world example you'll see constantly, the classic three-tier web application. Picture the flow on screen. Users out on the internet connect first to a load balancer, and that load balancer lives in a public subnet because it's meant to be reached by the public. That's its whole job. Behind it sit your application servers, the EC2 instances running your actual code, and those are in a private subnet. And behind them sits your database, also private. So the only thing the public can touch is the load balancer. The app servers and the database stay hidden away. This layered design is everywhere in production because it shrinks your attack surface down to just the one component that's supposed to be exposed. But remember what we learned earlier. Those private application servers still have errands to run. They need OS updates. They need to pull Docker images. They need to call external APIs. So how do they get out without becoming public? Through the NAT gateway, exactly as we traced before. The app EC2 instances send their outbound traffic to the NAT, which uses its elastic IP and forwards through the Internet Gateway out to the Internet. Meanwhile, and this is the payoff of the whole design, the Internet still cannot reach in to those private app servers or the database. They get everything they need to stay healthy and functional while remaining completely shielded from inbound attacks. That's the NAT Gateway doing precisely the job it was built for, inside a realistic architecture. Before we recap, here are a few practical things to keep in mind that trip people up in the real world. First, a NAT gateway lives in a single availability zone. That's one isolated data center location. So if that zone has an outage, your NAT goes down with it. For high availability, the fix is to deploy one NAT gateway per availability zone, so each zone has its own exit and they don't depend on each other. Second, a NAT gateway handles IPv4 only. If you need outbound access over IPv6, that's a different tool, an egress-only internet gateway. Third, and don't overlook this, it costs money. You're billed both per hour that it runs and per gigabyte of data that flows through it. That's exactly why, for traffic that's only going to AWS services, You should reach for VPC endpoints instead and route that traffic around the NAT to save on the per gigabyte charges. All right, let's pull everything together. Recap, Part 1. A NAT gateway is for private subnets. It serves the instances that have no public IP of their own. It provides outbound internet access only, that one-way exit we kept coming back to, where your servers reach out and replies return, but nobody can push in. And it lives in a public subnet, placed deliberately where the internet is actually reachable through the internet gateway. 3 ideas, and notice how they reinforce each other: private clients, one-way outbound flow, and a public home for the gateway itself. And recap, Part 2. A NAT gateway requires an elastic IP. That's the static public address it presents to the internet on behalf of all your private servers. It uses the internet gateway. The NAT doesn't reach the internet by magic. It forwards its traffic onward through the VPC's internet gateway. And critically, it blocks direct inbound connections. The internet simply cannot reach your private EC2 instances. Put the whole lesson in one sentence, and it's this: a NAT gateway lets your private servers reach the internet without ever becoming public themselves. That single capability is why it shows up in nearly every well-designed AWS network. And that's a wrap. Thank you so much for watching all the way through. I really hope the NAT gateway makes complete sense now, from what it is, to why private servers need it, to exactly how the traffic flows out and safely back. If this helped things click, please give it a like, share it with someone who's learning AWS, and subscribe for more cloud and AWS videos just like this one. Quick note before you go, this video is for educational purposes only. AWS, Amazon Web Services, and all related names, logos, and trademarks are the property of Amazon.com, Inc. or its affiliates, used here only for identification and teaching. This channel is not affiliated with, endorsed by, or sponsored by Amazon Web Services. Thanks again, and I'll see you in the next one.